Welcome everyone to the second part of our cloud computing learning series. If you are new to this learning series, then I would suggest you to please click on the I button and watch the first part of this learning series. You are listening to Vinay and I have more than a decade of proven experience in cybersecurity. That includes cloud computing and security services as well. I'm delighted to be here again today to walk you through cloud from scratch to advanced. Apart from this learning series, we have full learning path for cybersecurity and DevSecOps as well. To explore the same, please click on the I button and select the course playlist that meets your learning requirement. So why you should learn cybersecurity or cloud computing or any other security domain concepts from me? I have an MBA in information technology following my bachelor's degree in computer science and engineering from A-grade universities in India. I have many internationally recognized technical certifications from renowned organizations like Microsoft, NetApp, Exim, ISA Square, and many more. But more importantly, I have work experience in real world from banking to telecom industry to product manufacturing and IT consulting firms. As an innovative expert in cybersecurity strategy, transformation, and consulting, with total 12 plus years of experience, I have saved companies millions of dollars by pioneering first of their kind initiatives, combining business systems savvy with the latest technology and trends focusing compliance, ISO 27001, NIST cybersecurity framework, PCI DSS, GDPR, etc. I am skilled at devising and seamlessly directing the development of revolutionary solutions with maximized speed, efficiency, and cost effectiveness. Spearheading the coordination of people from all backgrounds and levels, on, and offshore bases alike. I have an outstanding track record of transforming concepts into state of the art realities, which produce quantifiable improvements in profitability, performance, and business potential. Striking the optimal balance between technical sophistication and user friendliness, I continually meet and surpass customer expectations. Experienced in areas spanning from R&D to sales, marketing, and business development, I have a unique ability to. Let's get to know about our course objective. Well, we are going to learn about the cloud. We are going to understand how cloud delivers business outcomes and why those business outcomes are such compelling drivers for organizations today. Things like efficiencies, scalability, ease of management, we will cover it all. And you, as an IT professional, I'm going to help you understand and gain some of the knowledge to understand how you, as a security professional or as an IT network admin, or if you like software development, or if you like database, whatever your IT strategy is and what you want to do in IT professional, I'm going to help you align and find out what your cloud strategy is by what we are going to cover in this course. And while I make no assumptions about who you are and why you might be taking this course, I think this course should be most useful to three type of people. First, this course is for anyone regardless of background who has an interest in cloud technology and security and wants to explore what it takes to be a cloud computing professional or a cloud security professional. Current IT professional looking to transition to a more exciting or lucrative career as also good candidates for this course. You will learn why cybersecurity professionals or cloud security professionals are in such high demand and why they may enjoy more job satisfaction than they would in other IT jobs. Finally, this course is there are 10 checkpoints in this full cloud computing learning series. In checkpoint 1, cloud overview, we are going to review who are the players and who are the organizations in race for cloud market share and their current share in the market today. We are going to review various cloud platforms such as AS, SaaS, PaaS, and compute as a service. And we are going to review modeling such as a private cloud, public cloud, hybrid cloud, and community cloud platforms. In checkpoint 2, characteristics of cloud computing, we are going to learn about critical cloud services such as Elasticity, pay as you grow, chargebacks, and cloud bursting. We are going to spend a lot of time learning cloud terminologies. In checkpoint 3, I'm going to give you an overview of key cloud players such as AWS, Azure, and GCP. We will learn about their history, core offerings, and if you are an IT professional, then I recommend you to put more focus on learning licensing. Also, we We will review their market strategies, their uniqueness like education and K312. In checkpoint 4, we are going to learn about cloud storage and we are going to learn about disk, read write operations, input output per second or IOPS. Also, we will take a look at various types of storage architectures such as directed attached storage, network attached storage, and storage area networks, SAN. In checkpoint 6, this is very important topic where we will learn about hypervisors and virtual CPUs and memory and storage and other things that make the virtual environment and the cloud possible. In checkpoint 7, we are going to take a deep dive into Amazon Web Services. We will learn about the entire Amazon product suite and we will look at things like simple storage service as 3. We are also going to learn about the platform and compute as a service, and we will learn about databases and data analytics and management tools and the front that we are going to use to manage all our Amazon product suite systems and services. In checkpoint 8, you are going to have more fun by taking a deep dive to Microsoft Azure, where we will learn about Azure product suite. We will learn about Azure security and identity solutions, and then we are going to look at Microsoft Azure's Clear Cloud and how that might help our organization's disaster recovery, continued operation, business continuity, and planning services. This is checkpoint 2, cloud characteristics. And before we go in depth into AWS, Azure, and GCP, we need to first understand key characteristics of cloud that are unique to the cloud but common to the cloud providers that you and me in IT are going to support. Cloud characteristics are all about the terminology and the technology that is needed for us in IT to be able to design, migrate, develop, utilize, optimize, troubleshoot, and support cloud services, applications, and most importantly, our end user community. In this checkpoint, we are going to cover elasticity, cloud bursting, pay as you grow, chargeback, ubiquitous access, multi-tenancy, and demand-driven services, and much more. To start with our cloud characteristics, let's understand the difference between elasticity and scalability. The purpose of elasticity is to match the resources allocated with actual amount of resources needed at any given point in time. Scalability handles the changing needs of an application within the confines of the infrastructure via statically adding or removing resources to meet applications' demands if needed. In cloud computing, elasticity means that your organization can dynamically provisions and stand up computer processing, memory, and storage to meet the needs of your organization. Elasticity is just one of the many benefits of cloud computing because it allows your organization to gain capacity without having to build up the computer and the storage resources is within your own data closet and within your own data centers. So, elasticity is the ability to grow or shrink infrastructure resources dynamically as needed to adapt to workload changes in an autonomic manner, maximizing the use of resources. This can result in savings in infrastructure cost overall. Not everyone can benefit from elastic services though. Environments that do not experience sudden or cyclical changes in demand may not benefit from the cost savings elastic services offer. Use of elastic services generally implies all resources that in the infrastructure be elastic. This includes but not limited to hardware, software, QoS, and other policies, connectivity, and other resources that are used in elastic applications. This may become a negative trait where performance of certain applications must have guaranteed performance. It depends on the environment. Cloud elasticity is a popular feature associated with scale out solutions, horizontal scaling, which allows for resources to be dynamically added or removed when needed. Elasticity is generally associated with public cloud resources and is more commonly featured in pay per use or pay as you grow services. This means IT managers are not paying for more resources than they are consuming and any given time. In virtualized environments, cloud elasticity could include the ability to dynamically deploy new virtual machines or shut down inactive virtual machines. A use case that could easily have the need for cloud elasticity would be in retail with increased seasonal activity. For example, during the holiday season for Black Friday spikes and special sales during this season um, can be a sudden increased demand on the system, right? Instead of spending budget on additional permanent infrastructure capacity to handle a couple months of high workload out of the year, this is a good opportunity to use an elastic solution. The additional infrastructure to handle the increased volume is only used in a pay as you grow model and then shrinks back to a lower capacity for rest of the year. This also allows for additional sudden and unanticipated sales activities throughout the year if needed, without impacting performance or availability. This can give IT managers the security of unlimited headroom when needed. This can also be a big cost saving to retail companies looking to optimize their IT spend if packaged well by the service provider. Whereas cloud scalability is, for example, when the host has been provisioned with your computer as a service with its compute memory and storage resources, is only currently a 50% utilization. Thus, your host can have additional virtualized machine turned up until you are closer to capacity. Scalability includes the ability to increase workload size within existing infrastructure, hardware, software, etc. without impacting performance, of course. These resources required to support this are usually pre-planned capacity with a certain amount of headroom built in to handle peak demands. Scalability also encompasses the ability to expand with additional infrastructure resources, in some cases without a hard limit. Scalability can either be vertical, scale up within a system, or horizontal, scale out multiple systems in most cases, but not always linearly. Therefore, applications have the room to scale up or scale out to prevent a lack of resources from hindering performance. There are cases where the IT managers knows he or she will no longer need resources and will scale down the infrastructure statically to support a new, smaller environment, either increasing or decreasing services and resources. This is a planned event and static for the worst case workload scenario. For example, there is a small database application supported on a server for a small business. Over time, as the business grows, so will the database, right? And the resource demands for the database applications as well. If the IT manager knows based on the growth rate of the business and or the database, he may purchase he may purchase provisioned infrastructure, compute, network, and storage so that the database applications has the room to grow to its maximum performance and capacity expected. In other words, scale up performance without having to worry about not meeting SLAs in a steady pay as you grow solution. Another use case is a virtual desktop infrastructure VDI. There are an expected number of desktop based on employee population. To ensure the ability to support the maximum number of users and meet SLAs, the amount of services purchased must be enough to handle all users logged in at once as a maximum use case. In short, the amount of resources allocated are there to handle the heaviest predicted load without a degradation in performance. So that is the core meaning of scalability. So where elasticity and scalability cross paths. So, cloud services are considered adaptable solutions where both scalability and elasticity are offered. They allow IT departments to expand or contract their resources and services based on their needs, while other offer pay as you grow to scale for performance and resources need to meet SLAs. Incorporation of both of these capabilities is an important consideration for IT managers whose infrastructure are constantly changing. Do not fall into the sales confusion of services where cloud elasticity and scalability are presented as the same service by public cloud providers. There are distinct differences between elasticity and scalability, and you should understand those. It depends on the business need or use case whether elastic or scalability services will be the best choice. A rule of thumb can help you make that decision. Cloud scalability is generally delivered more readily in private cloud environments, while cloud elasticity is generally delivered more readily in public cloud environments. With with data accumulating quicker than ever and data breaches looming around every corner, many businesses are starting to turn to cloud service providers to help them with their data and storage needs. One major issue with many suppliers, however, is service contracts. These contracts can lock businesses into more services than required just in case they grow. And if you do grow, you might outgrow your contract and be left paying expensive overage fees. Overall, these contracts are usually too confusing and convoluted to be useful for a growing business. Luckily, there's another method for companies that require a bit more flexibility, pay as you grow or pay as you go cloud computing. Typical cloud computing contracts are similar to wireless phone contracts. You pay for a certain level of services, including specific data caps. If you go beyond your contract, you will need to pay an accelerated overage fee or upgrade your contract completely. This structure leads to confusing payment structures and makes it difficult for businesses for who fluctuate in data uses or are steadily growing. Pay as you go, however, is much more straightforward. You pay only for the data you use each month, just like your electricity bill. Your bill varies each month by amount you use. You have more control over your cost and fewer surprises. Pay as you go has several benefits over other cloud service provider contracts. Most obviously, there is the pricing. You save money by only paying for the data that you use, and you will have the peace of mind that comes with a set, simple contract. Another benefit is how customizable a pay as you grow a pay as you go plan can be. Unlike other plans, you can plug and play your cloud solution. If you only need to utilize it for a special deployment or a couple times or a month, you will be able to do so. Finally, pay as you go or pay as you grow is extremely scalable. Your plan is specifically built to accommodate for fluctuations and enormous growth. If your business plan is to grow, being set in an inflexible contract can really set you back. So, the Oracle Cloud is a cloud computing service offered by the Cloud Corporation, providing servers, storage, network applications, and services through a global network or Oracle Corporation managed data center. The company allows these services to be provisioned on demand over the internet. The Oracle Cloud provides infrastructure as a service, AS, platform as a service, PaaS, software as a service, SaaS, and data as a service, DaaS. These services are used to build, deploy, integrate, and extend applications in the cloud. The Oracle Cloud Platform supports numerous HOAP. Its standards such as SQL, HTML5, and REST, and open source solutions such as Kubernetes, Hadoop, and Kafka. The Oracle platform supports a variety of programming languages, databases, tools, and frameworks, including Oracle-specific open source and third-party software systems. So let's understand how we charge our IT teams for their cloud services. So an IT chargeback is an accounting strategy that applies the cost of IT hardware, software, cloud services, or shared services to the business unit in which they are used. IT showback is similar to IT chargeback, but the prices are for informational purpose only, and no one is billed. This accounting system enables organizations to have better visibility and understanding of how their IT dollars are truly spent instead of a single IT budget. Charging the services to the team that uses them or back allows an IT organization to determine, for example, how much platform as a service was used by dev team or how much compute and storage was used by the application customer experience team. Instead of just a bill for this month's cloud services to company X, without a chargeback system, all IT costs are consolidated under the IT department umbrella, and the ability to determine the true profitability of the individual business units and IT department support is limited. So, I know you are thinking that if I wanted to study accounting, you would have learned Microsoft Excel pivot tables, of course, and that you thought IT was supposed to be about technology. I hear you, and there's a point to all this accounting stuff, I promise. But for now, please also know that metering is actually one of the ways that cloud providers and consumers tracks their use. Metered billing allows organizations to see where their money is being spent by automating workloads, ensuring money isn't being spent when workloads aren't in use, creating alerts that notify when spending limits have been reached, storage costs have gone past a certain point, instances go unused, or use of an instance may require a change in pricing structure, and determining areas where a lot of data is housed, which is where junk files may be lurking and ripe for deletion. Of course, a reputable provider should help an organization right size, that is, identify poorly provisioned resources and reconfigure them to optimum levels. The provider will conduct a thorough investigation into your resources, analyze them, and provide recommendations. So, the point of all this accounting stuff is chargebacks and metering are the end result of one of the most amazing cloud characteristic, cloud analytics. Analytics, the real-time reporting on metadata, data about data, and the cloud has the best analytics and business intelligence out there. It's not that my own network does not have enterprise class BI business intelligence. The reason why the cloud's analytics are so amazing is that my IT team didn't have to build it. Building out a comprehensive end-to-end analytics based network management system in a mass is a real dining task for the enterprise, and I know you agree to me. I need analytics and BI software. I need lots of expensive storage because I create and then need to store so much monitoring, alerting, and accounting data about my data. Now, let's bust some clouds. Cloud busting is a configurations which is set up between a private cloud and a public cloud to deal with the peak in IT demand. If an organization using a private cloud reaches 100% of its resource capacity, the overflow traffic is directed to a public cloud, so there is no interruption of services. In addition to flexibility and self-service functionality, the key advantage to cloud busting is economical savings. You only pay for the additional resources when there is a demand for those resources. No more spending on extra capacity you are not using or trying to predict demand peaks and fluctuations. An application can be applied to the private cloud, then bus to the public cloud only when necessary to meet peak demands. Plus, cloud busting can also be used to shoulder processing burdens by moving basic applications to the public cloud to free up local resources for business critical applications. When using cloud busting, you should consider security and compliance requirements, latency, load balancing, and platform compatibility. Banks are the perfect use case for cloud busting because they process large volumes of data about things like interest rates, return, and risk-weighted assets. This data isn't personal but requires frequent short bursts of compute power to meet compliance reporting requirements. Most banks can't justify the capital expense of investing in on-prem capacity to process data. That only comes in intermittently, knowing that hardware will mostly remain idle. On the other hand, running a 24 by 7 technology stack in the cloud racks up too much operating expense. Cloud busting not only strikes the perfect balance between storage capacity and cost, it gives data scientists a space to play and gain new insights. Let's look at some cloud elements that make the cloud so compelling to today's enterprises. So we have talked about the cloud gets visibility and pay for use billing, just like a service utility. And we worked through the concepts of cloud elasticity and cloud busting to scale up and then scale your network using the public cloud and its amazing platform as a service capabilities. What we are going to learn now is about cloud virtualization, cloud management automation, and the cloud's do it yourself model of self provisioning and self service. So, according to the CompTIA Cloud Plus certification written by Scott Wilson and Eric, a great read, by the way, and I am a big fan of the Cloud CompTIA IT certification program. These are the cloud elements that will become the uh, cloud control and management tools in our cloud environment. An element is the resource, and the target is that resource in the cloud that we point to for the purpose of management and control. A hypervisor is the underlying operating system that manages our virtual machines, and we or the cloud maintains through the services such as patch management. We will talk more on that later. Virtual resources is of the target object for a cloud management tool that collects resource utilization metrics, benchmarks, and uses and performance thresholds. A virtual machine, such as a server platform our DevOps team is using to develop its new software, would be a great object for a cloud backup solution to ensure we have configured the cloud's best practices for cloud continued operations, co-op, and business continuity disaster and recovery BCDR. A cloud-based virtual appliance like a firewall, CASB, Access Security Broker, WAF, Web Application Firewall for our web applications, and load balancers for the sharing of the of traffic across redundant paths to our public cloud resources are all virtual appliance targets for management services such as our cloud dashboards. Cloud storage can be targets for dashboards, for visibility, and for the monitoring and reporting of your cloud data backups. Recovery point and recovery time objectives, RPOs and RTOs, more on that later is coming. And Elastic's provisioning tools to scale out more storage when you and your organization need it. So an element is a cloud resource, any cloud resource that we might want to manage and have visibility to either in our cloud dashboards or in our cloud accounting tools. Cloud targets are the cloud elements we are actually controlling and reporting on. Our business's virtual machine, for example, that is in AWS platform. And remember that there is a bridge between our business's private cloud, our network, and the public cloud. That bridge allows us, for example, if we have a security compliance tool like a CM that analyzes and reports security incident in our internal network, there are bridges between our network and the cloud that allows our CM to pull security incidents and event and logs and pull that data from the cloud so that we can report on security state of our services and our data in the cloud. So our network via public cloud bridging is reporting using our own business intelligence. And you thought we are just going to learn about accounting principles and spreadsheets. Not at all. I really like these two images that I found with the power of a browser and an internet search engine. As they say, just use the amazing GTS protocol and you are there. Cloud operation management is concerned with designing, overseeing, controlling, and managing your cloud operations. The goal of cloud operations is to ensure the efficient use of cloud resources as well as meeting your organization's quality of service and service level agreements. Cloud operations management is all about cloud customer satisfaction through the management of the hardware, software, and network infrastructure in the customer's cloud environment, promoting efficiency and a lean and mean cloud environment. So a couple of more cloud elements that are unique to cloud are self-provisioning and self-service. Self-provisioning or a self-servicing cloud environment allows knowledge workers to do for themselves what once took weeks or even months of coordinated activity. Provision and manage the IT resources needed to complete their task. But the benefit of self-service doesn't end there. There is a wealth of opportunities with cloud self-service that cannot be supported by traditional IT infrastructure. The cloud is built to deliver speed and simplicity that really takes advantage of the desire for self-service for the cloud consumers, and the traditional environment that requests a new resource must be submitted to IT, that then needs to be assessed to a budget evaluated and then approved by management. Hardware and software is then to be identified and purchased, and that a bunch of man hours are used to stand up the solution and manage the new project to conclusion. And that doesn't include all the testing and all of the other life cycle phases of a project that are necessary to roll new tech. We are going to spend a lot of time in dashboards in future course videos of this cloud computing learning path. So get ready for self provisioning and do it yourself simplicity of the cloud. So when the cloud means self service, it really is the definition of self service. If you don't like dashboards that are available when using the native dashboard management tools, well, then via API application programming interfaces, you can write your own dashboards and create your own unique cloud business experience. Neither every tool meets uh, every business requirement, nor every tool delivered on every business outcome in the exact way each unique business requires it to do so. The cloud self-service and self-provision suite of, if end user controlled, managed, and even custom integrated tools, is one of the cloud's defining customer compelling elements. So thus far in this cloud computing learning path, I want you to remember the power of cloud analytics and how the cloud empowers IT organizations via do it yourself simplicity. The cloud self service approach to delivering on your business outcomes so good. Now we are going to learn about baselining network operations and network services, and we will be knowing about cloud characteristics of multi-tenancy. So what is a network baseline? The definition of a network baseline is a set of metrics that describe normal operating parameters. Setting the baseline enables engineers to catch changes in traffic that could indicate an application performance problem or a security breach. There are some questions that your network baseline should address about your network in your network operations, like what is normal, how do I measure normal behavior in my network, and what is abnormal network behavior, and what is abnormal behavior look like. Abnormal behavior can mean a lot of things to me as a network administrator or a security professional. Abnormal behaviors could mean that I have down services or down systems. I could be seeing unusual demands on my network, thus the peak in utilization or the opposite. I have this large valley of network under utilization and underperformance, meaning I might not be delivering the network services to my end user demands. So they have given up and are no longer using the network to its full potential. How do I measure network performance, and am I all about speed? Or am I also looking at the metrics like latency or delay? Or is it end user key response time that keep my paychecks coming 26 times a year? Or maybe it's availability and reliability. What are my performance levels, uptime and downtime across the services in my network? This leads us to key performance indicators, KPIs, and what are the metrics my organization is going to hold the network accountable for to get the service level agreement or SLA. And unless I have penciled out what your network performance goals are, how do I measure how I'm actually delivering on those goals? Where is the network winning and where is the network losing? And without all this information, I cannot accurately and clearly quantify risk. Without knowing the performance goals and KPIs that build the foundation of network service level agreement, how can I expect to shift any of this network responsibility to a service like the public cloud? If I'm not measuring it, I will never be able to deliver it. Whether the service is driven by our own network or by a cloud service provider. So this is how it goes. There are tons of network measuring, scanning, and monitoring tools out there. There are dozens of open source tools you can start playing with, like PRTG and Spiceworks, and almost every in a mess out there offer free trials before your licensing goes active. You might have to deal with advertisements and pop-ups with your free versions, but you can get started working on your baseline without a big upfront capital outlay. There are some very amazing and enterprise solutions out there that can do it all. For real-time network monitoring, alerting, and reporting, thieving having built-in service ticket and help desk tracking systems. So, how did baseline system work? Well, the majority of them use network sensors in these lightweight pieces of software you install called agent. If you want to measure a WAN link between your primary network closet in your business high rise and the backup data center across town, you would install agents on each side of the link on computer systems that are running, and then these agents place IP calls between them and measure things like delay, variable delay, know by the term jitter, and a packet loss. Each of these different measurements could mean you have issues in the wide area network, hop by hop between your office and the backup site. Our problem could be something as simple as a bad patch cable in the closet, or something more serious like when router is suffering from memory leaks. Another way these network management systems and monitoring tools can work is by the use of network sensors. There are actually physical network devices or sensors that you can plug into a network port on a switch, for example, and start reporting to properly configured network management system. But in most cases, what we mean by a network sensor is a software sensor. PRTG, for example, uses more than 500 software sensor types. For example, the use of PRTG's ping sensor will check the availability and uptime of your servers and other devices by running regular ping tests. There are numerous SNMP, Simple Network Management Protocol, and WMI sensors that will allow you to measure metrics such as free space and hard disk, CPU memory load, temperatures, and bandwidth uses, and packet sniffing sensors enable you to monitor and analyze bandwidth consumption, broken down by protocol and IP address. So, what the proper use of network baseline tools, whether it be packet sniffers to full-blown network monitoring and management systems? Our IT organization will build over time a baseline of how our network behave, and will glean from this information the key performance indicators that are unique to our organization, our services, and how those services perform is what our IT organization really cares about. And here's where we are going with all this. Now that we have the baseline information, we have real measurements and real metrics that can be used in the negotiations with our cloud provider on the services we need, and the cloud provider SLAs around our cloud needs. If it's availability we care about, well, what is the cloud provider uptime? If it's performance, what kind of network connectivity organization need to deliver on cloud response times? And with our cloud performance as a service, how much CPU, RAM memory, and disk storage do we require to move our business critical applications from on-prem to being cloud delivered and cloud managed? Having a successful network baseline is a fundamental requirement of an organization to have successful cloud adoption and successful cloud business outcomes. In cloud computing, multi-tenancy means that multiple customers of a cloud vendor are using the same cloud computing resources, despite the fact that they share resources. Cloud customers aren't aware of each other, and their data is kept totally separate. Multi-tenancy is a crucial component of cloud computing. Without it, cloud services would be far less practical. Multi-tenant architecture is a feature in many types of public cloud computing, including IaaS, PaaS, SaaS, containers, and serverless computing. To understand multi-tenancy, think of how banking works. Multiple people can store their money in one bank, right? And their assets are completely separate, even though they are stored in the same place. Customers of the bank don't interact with each other, don't have access to other customers' money, and aren't even aware of each other. Similarly, in public cloud computing, customers of the cloud vendor use the same infrastructure, the same servers, typically, while still keeping their data and their business logic separate and secure. The classic definition of multi-tenancy was a single software instance that served multiple users or tenants. However, in modern cloud computing, the term has taken on a broader meaning, referring to a shared cloud infrastructure instead of just a shared software instance. Many of the benefits of cloud computing are only possible because of multi-tenancy, such as better use of resources. One machine reserved for one tenant isn't efficient, as that one tenant is not likely to use all of the machine's computing power. By sharing machines among multiple tenants, use of available resources is maximized. Then lower cost. With the multiple customers sharing resources, a cloud vendor can offer their services to many customers at a much lower cost than if customers require their own dedicated infrastructure. Thank you, everyone. If you have got any query or concern, then always remember the fastest way to reach out is the comment box. Pick up your keyboard and start typing in the comment box. I will get back to you at my earliest. Alternatively, you can drop us an email at cybitcyber@gmail.com. Also, do not miss to subscribe to our channel and press the notification bell icon to be aware of any new course that we will publish. You can connect with us at LinkedIn, Facebook, Twitter, and Instagram to get yourself updated with latest cybersecurity industry trends, documents, and various articles. You should use our unique ID. Cyber to find us and connect with us on these social media platforms. Please subscribe to our YouTube channel, Cybersecurity. Press the notification bell icon, like the video, and let's cyber the cyberspace in a whole new way and build this learning loving community together. Thank you so much for watching. Happy learning.